Everyone's exhausted. Let's do this problem and go home. You go, really? I go, yes. You do it. You get it right. We'll go home. Find the derivative. Oh, you work on it. I'll be back. I'll see you on Thursday while you work on it. Don't leave yet till you get it right. You're going to be here for a long time. The chain rule is actually going to help us do that in less than a minute. The chain rule says if you want to find dy dx, you can do that by, that's equal to dy times du times du times dx. Notice if you do the math, what will happen to du's? When they cancel each other out, you end up with dy dx. So how is that going to help me? Well, what the chain rule is telling us, you didn't see it yet. Yes, you know what? You have y equals this problem. Let's let u equals x squared plus 50. If you do that, then you can take y and write that as what? U to the power of what? 240. Do you agree with that? If you let u equals what's inside of this, x squared plus 50, then I can write y equals, in place of this, u to the power of 240. To take the derivative of this is called now du dx, because u is not a y here, it's a u. The derivative of this is du dx. And what's the derivative of x squared plus 50? Isn't that 2x plus 0? Which is 2x. The derivative of x squared is 2x. The derivative of 50 is 0. So I don't need the 0 there. I can take it out. What's the derivative of this? It's u equals, instead of x to the 240, it's u to the 240. So the derivative will not be called du dx, will be called, not dy dx, will be called dy du. It's this with respect to this. And just like if this was x to the 240, you move the power to the front and you subtract 1 from the power. Now you want to find dy dx. This one says it's dy du times du dx. What is dy du? It's right here, you see it? Times, what is du dx? Isn't it 2x? What's 2x times 240? Is that 480? X times u to the power of 239. The only thing I need to do now, when we started the problem, look at the problem. There's no mention of u. There's nothing. Your answer has a u in it, so you can't relieve the u in it. You got to change it back to x. What is u equal to?
X squared plus 50.
So yep, take the u out, put x squared plus 50. So that's where the chain rule comes in. When the power is more than 1 and you don't want to multiply that 10 times or 15 times, you go, I got to do this method. Or, if you have this problem, these are my problems, I'm making them up here. having fun with them. Can you tell me what dy dx is? Again, you can take this problem, write that 2x squared plus 5 to the power of what? 1/2. So the chain rule, you want to use it when the power is different than 1. If the power is 1, you're wasting your time. There's no need for it. But if the power is different than 1, that's a good place to use it. Dy dx, we said that's dy du times du dx. So let u equals 2x squared plus 5. If you do that, then y will be written as what? U to what power? 1/2. Let's find the derivative of each one. That's a 4x. Let's find the derivative of this, dy du. It's 1/2 u to what power? Negative 1/2. Now come back to this and plug them in. What is du dx? 4x. And if you clean this one, just mathematically, if you clean it, that's 1 over what? 2. Isn't that u to the 1/2 in the bottom, or the square root of u? And the only thing, again, we got to do now is take u out and put the value of u, which is what? Yep. And if you want to multiply, we can put the 4x on the top, right? And if you want to simplify, does anything simplify? Can't you divide by 2? By 2, this is 1. By 2, this is 2. So it's really 2x over the square root of 2x squared plus 5. One more example. Y equals, let's say, negative 7 over 2x minus 3 squared. What rule can I use here? Can I use the quotient rule? Sure I can. Do I want to use it? Not really. No. It's going to take a whole page. I can write this negative 7, 2x minus 3 to what power? Negative 2. The power is different than 1. Chain rule is a flag. Maybe I should be using that. Let u equals 2x minus 3. The derivative of that is what? 2. Let y equals what? This becomes negative 7. In place of 2x minus 3, that becomes u to the power of negative 2. What's the derivative of this? 14u to what power? Negative 3, or 14 over u to the third. dy dx equals dy du times du dx. dy du, what's that? 14 over u to the third times du dx, which is what? 2. 28 over u to the third, and what's the last step? 28 over 2x minus 3 to what power? 3. Now here's the good news. Bad news, depends how you look at it. Wouldn't do them this way. There's even a quicker method than this. Still works. Remember this problem? Ready for this in one step? Let me write it down. Let's see if we get the same answer. It is the chain rule, but nobody wants to go let u equal this, let du, dy, dx. If this was x to the 240, how would you take the derivative? If this was x to the 240.
239.
Or 240 times x to the 239, right? We're still going to do the same thing. We're going to move the power to the front, multiply it by x squared plus 50 to the power of what? Subtract 1 from the power. But that's not the same answer. Got a portion of it. Something is missing. So the only extra thing I've got to do is multiply it by the derivative of what's on the inside of that. And what's the derivative of this?
2x.
Times the 2x. What's 240 times 2x? 480x times x squared plus 50 to the power of 239. Was that the answer?
Yeah. Cool beans, man.
Let's try the other one. See if we get the same answer. We said that's 2x squared plus 5 to what power? 1/2. So what's the derivative of that? Take the power, move it to the front. And subtract 1 from the power. What is 1/2 minus 1? Negative 1/2 times the derivative, what's on the inside of that? 4x. Done. 4x and 1/2, that'll make it what, 2x? If you don't like negative exponent, you can make it what? 2x over the square root of 2x squared plus 5. Was that the same answer? Yes. The last one. Can do them either way. Still the same section. No, the same section. That's still 4. You can write that negative 7 2x minus 3 to the negative 2. And here we go. The derivative in one line. Negative 2 times the negative 7.
14.
That's 14.
2x.
2x minus 3. That doesn't change to what power?
Negative 3.
Negative 3 times the derivative. What's on the inside?
2x.
2. 2 times 14 is what?
28.
28 times 2x minus 3 to the negative 3, which you can write that 28 over 2x minus 3 to the third power. This method has a name. It's called the extended power rule. It says if you want to take the derivative of a function, the derivative of a function raised to the power of n is going to be n times the function to the power of n minus 1, subtract 1 from it, times the derivative what's inside of that. That's the part you have to remember, the derivative what's on the inside. A lot of people forget that little part. They go 240, yep, subtract 1 from the power, 239, but they forget to multiply by the derivative of this. So you always have to multiply by the derivative what's on the inside. The derivative what's on the inside. If you remember that part, that is the quickest way to take a derivative of something raised to the power different than 1. And we'll stop here.